methods to multiply binomials. They teach distributive property, and then they teach foiling. And so you've probably seen both of these. With distributive property, you're literally distributing each piece of the first one into the second one. And then FOIL is the little acronym that you learn, first, outer, inner, last. So we're going to do it both ways. All right, so the first way we are just distributing. So you're going to distribute it a piece at a time. So we would distribute this 2x, and we would distribute it through to both pieces of the second one. So I would say 2x times x plus 2x times 4. All right, and then distribute the 3, and you're going to distribute that to both pieces. So you're going to say 3 to both pieces. So 3 times x plus 3 times 4. All right, so that's just repeated distribution. You are literally distributing each piece of the first one into the second one. And so you're going to simplify it. This is where your properties of exponents come into play. X times x, it's both to the first power. You add your exponents. So I have what here? 2 times x is 2x squared. Then I have 2x times 4. I just multiply those coefficients. This is just becomes my 3x. This is my 12. I am still not done because I still have like terms. Remember we talked about standard form, highest degree to lowest, and no terms that haven't been added together if they're alike. So these are like terms. 2x squared plus 11x plus 12. That is just repeated distribution, All right, and so go ahead and try those. They've given you 3 doing that method. Distribute the first term, distribute the second term. Watch your positives and negatives when you are distributing a negative. All right, let me go through the answers and then we'll see if y'all have questions. The first one, you should have gotten 12h squared plus 4h minus 21. 40m squared plus 11m minus 2. And 63a squared minus 20a minus 32. Let's do it together. So the first thing we're going to distribute is the 6h. You'll say 6h times 2h plus 6h times 3. Then we're going to distribute the negative 7. So we have negative 7 times 2h. Negative 7 times 3. All right. This becomes 12h squared. 18h, negative 14h, negative 21. Combine your like terms. You get 12h squared plus 4h minus 21. All right. Next one. So for this one, we are going to distribute for C. This is the next one y'all wanted to see. 9a. All right, so we have 9a times 7a, 9a times 4. Then we're going to distribute a negative 8. So negative 8 times 7a. Let's get this over. A negative 8 times 4. And then you are going to simplify. So this becomes 63a squared, 36a, negative 56a, negative 32. And then when you combine your like terms here, 63a squared doesn't combine with anything. These two combine for negative 20. This doesn't combine with anything. It stays by itself. So once you've done your FOIL method, you're going to simplify at the very end. And so your final answer will look like this. And so FOIL is simply doing this process right here. And this should be familiar because this is one of the most common ways to teach this particular process. First, outer, inner, last. All right. So go ahead and try those 4 using the FOIL method. First, outer, inner, and last. So these are all positives. When you distribute, you end up with all positive monomials, and then when you combine like terms, right? The only thing that changed here is the first term had a negative. And so when I distributed the -4, I distributed that through, which meant my last two terms ended up being negative. And instead of adding these two terms, which is what I did here, I subtracted them, which is what gave me the 7. And then my last term was a negative, because a negative times a positive is a negative here. So when I multiplied positive times a positive, I added my two inner terms, and my last term was positive. When I had a negative times a positive, I subtracted my two inner terms, and my last number was a negative. Here, my second one had a negative. And so I ended up still subtracting my two inner terms, but instead of having a positive 7x here, I had a negative 7x because my greater term was negative. My last one was still -20 because it was still a positive times a negative. Here was two negatives. I actually ended up adding my middle terms here because they had the same sign, -15 and -8. And then my last term ended up being positive because a negative times a negative is a positive. And so while these looked like the same four problems, they ended up all being different with positives and negatives. And so when we start to factor, which is what we're going to do next week, this will come into play. All right, so here they want the area of the shaded region. All right, in order to find the area of the shaded region, what we're going to have to do is we're going to have to find the area of this whole big rectangle, and then we're going to have to subtract the small rectangle, and that will be what's left over will be this shaded region, okay? And so if we're going to find the area of the large one, we're just going to multiply base times height. Multiply your two dimensions here, and that will give you the area of the large rectangle. And then we're going to subtract from that the area of the small rectangle, and we're going to do those as well, those dimensions as well. All right? And so when you have something like this, you almost want to think of it like order of operations, okay? What's happening in between these two is multiplication. What is happening in between these two is multiplication, okay? So order of operations says I need to do my multiplication first, and then I will worry about the subtraction, okay? And so you can think of it that way. The other way you can think of it is distribute the negative through, and that sometimes gets a little confusing. So we'll just do our foiling and all first, our distributing, and then we'll worry about it. So foiling, I'm going to say first, 2x times 3x, that's 6x squared. Outer, 2x times 1. Inner, 5 times 3x. And last is 1. All right? And so that's my first group, and I'm going to subtract my second group. Now doing this, it's multiplication, so order doesn't matter. So I'm actually going to distribute this way, which is fine. If it's at the end, just distribute. X times x is x squared. X times 2 is 2x. All right, questions on that first part? Yeah. So my like terms, I'm going to say 6x minus. Now, if you want to do adding the opposite, if you struggle with positives and negatives, right, you can change this to plus a negative and a negative if you want to. All right. So 6x plus a -1 is 5x squared. I have a 2x, and a -2. So I'm going to say 2 plus 15, 17, minus 2 is going to give me 15. So combine all your like terms there. The 5x does not combine with anything, so we're just going to leave it as a 5. This represents the area of the shaded region. So for any variable that I put in, if I were to put in a 2 into all of my x's, then the area of the big one minus the area of the small one would equal that. And if I plugged in a 2 in for this, you would see that that equals the same number. All right? So when you have multiple things going on, do your multiplication first or your distribution, and then worry about subtraction or addition. It's just like order of operations. So go ahead and try 3, A and B. For this one, you'll notice the first one. So for this one, we have a trinomial and a binomial. All right, so they actually teach two methods and I don't teach two methods here. I actually rearrange them. So remember with when we learned way back at the beginning of the year, multiplication is commutative, meaning order does not matter. So 2 times 3 is the same thing as 3 times 2. And so if I have a trinomial times a binomial, it's the same thing as if I do the binomial in front and then the trinomial. It's the same thing. So that's actually what I do here. I just do the 2x minus 3 right here and the 4x squared plus x minus 6. So I always put my smaller one in front, all right? And then I just do repeated distribution. So what I'm going to do is I'm going to take this 2x and I'm going to distribute it through to all three of them. And then I'm going to take the negative 3 and I'm going to distribute that through to all three of them. All right? And so I'm going to say 2x times 4x squared plus 2x times x plus 2x times negative 6. And then I'm going to add to that my negative 3 times 4x squared, negative 3 times x, and negative 3 times negative 6. Pay attention to your negatives. Obviously, I'm writing it all out. You don't necessarily have to, but pay attention to your positives and negatives as you do this. Combine these guys with multiplication, 2x and 4x squared. This is your properties of exponents. This is going to be 8x cubed, right? Because I have x to the first and x squared. 8x cubed. Then I have 2x squared and then negative 12x. I have negative 12x squared, negative 3x. This is negative times a negative, so I have positive 18 there. And then I'm just going to combine like terms. So at this point, I'm going to look for anything that has an x cubed. There is nothing else with an x cubed. So I have 8x cubed. You'll notice that I'm underlining them as I go. With ones that are this large, sometimes you forget something that's in the middle. So the reason I'm underlining it is so that I know that I have counted that when I get to my final answer. So 2x squared, what's a like term to that one? So 2 and negative 12 is negative 10x squared. What about negative 12x? Negative 12 and negative 3 are what? Same sign, add them. Yep, 15x, right? And then this doesn't combine with anything, so you just add it at the end. All right? So it's going to be a big answer, and that should be a squared, by the way. But this is your final answer here. This is as simple as you can get it, okay? Remember, when you are adding like terms, your exponents do not change. So I've had people that tried to like add the 2x squared and the negative 12x squared and they made this a fourth. No, that's only when you're multiplying do you change your exponents. When you are adding, exponents do not change.